can start. Okay. Okay, second step. Go here on attributes. So mesh. We want to mesh a line. So please select mesh line. Okay. There are several structural element types here. If you click here, you can select the most several elements. Today we will use thin beam. Okay, here at first, at least we will use this thin beam. Thin beam means only bending deformability in addition to axial deformability, but for straight beams, axial and transverse behaviors are decoupled. So with respect to transverse forces, we can have bending and shear deformabilities in general. If you neglect shear deformability and take into account only the bending deformability, you deal with thin beam in Lusas, and you use the Euler-Bernoulli theory. Okay. If shear and deformability is also included, we use the Timoshenko beam theory. Okay. So please select thin beam. Then here, number of dimensions is 2, because we are dealing with a plane, a 2D problem. So two-dimensional is fine, is okay. Interpolation order is quadratic. What does it mean? It means that, as I told you last week, displacements must be, nodal displacements are the unknowns of the problem. Once they have been found, in order to get the displacements also between each couple of nodes, you need to interpolate them. And several interpolating functions can be used. In general, they are polynomials, but not always polynomials. In general, here we have for this element a quadratic interpolation. Okay. Please note that the element name in the library is BM3. So if we search for BM3 in the help, I will show you. We can see all the properties. Okay, for this element. On the right, sorry, we have other options. For the moment, just leave the number of subdivisions as the default one. So 4 subdivisions. We will add more comments on the number of subdivisions later on, okay, in the future. So for today, for the moment, just leave 4. And what I want to do is to change the name here. I will call it thin beam. 4 subdivisions. Thin beam 4 subdivisions, okay? You can now click apply and OK, or directly OK. Apply, OK. Here, please note that on the left here, there is the attributes tab here. If you go on the left and activate attributes, the new thin beams 4 subdivisions mesh of line appeared. You can see here a new attribute, the one that we created. Here we can assign the attribute once created, or we can create several attributes and assign them in a second time. Okay. For example, if the attribute has been created, like here, it will appear and this symbol will stay gray. Okay. If you assign the attribute to one or more elements, one or more line geometries, it will be colored. It will appear with colors. So to assign the attribute, you can, on the main window, select the line. As you can see, it is in black. Select, then go here, and by clicking on the right button, you can do assign or assign to all, in this case, assign. Otherwise, you can simply paste this attribute in the main window, okay, here. And so, in this case, as you can see, it became colored, and in the left box, you see mesh completing. You can read mesh completed, okay? So this line was meshed by thin beam elements with 4 subdivisions. So here, between points 1 and 2, there are 4 finite elements, and so 5 nodes, okay? 5 nodes. I wait for a while. I want to show that if you click on top right here, help topics, on the left you have the guide. Here there are many manuals. For example, the getting started guide here, the modeler reference manual, which means here suggestions on how to create models. Then there is also an examples manual here and application examples on several fields like bridges, civil and structural, and so on. There is also a specific application manual here with several examples, and below there is also the element reference manual with all the finite elements contained in the LUSAS library. Okay, a lot of elements. So you can go here on beam elements and read everything you want. Theory manual 1 and 2, these are theory manuals in the sense that they contain structural mechanics and finite element theories. Okay, so here this is the main. These are the main contents. If you click on index here or contents, I simply type the name of the finite element that we selected, which was BM3. By typing BM3, give me a second here, I need to move it here. Okay, you have 2 possibilities, Kirchhoff beam and Kirchhoff thin beam. Thin beam is our case, Kirchhoff means like Euler-Bernoulli, so only. Here, BM3 in general is a 3-node carved beam. In our case, we attached it to a straight line, but in general, it could also be used for curved beam axis. Okay. Here you have all the information. So number of nodes, degrees of freedom per node, and everything concerning these elements. This could be done for any finite element in the code. Okay. Before I told you that we subdivided the beam into 4 elements, and so we had 5 nodes. I was wrong because this finite element has 3 nodes. So in general, you will have 3 times 4, 12 nodes. Okay, but please consider that here the node number 2, the central one, is only for geometry, and the nodes for calculation are 1 and 3. So 2 nodes for calculating the solution. Okay. If I'm not wrong, it should be like that, if I remember well. Okay. Anyhow, here you have all the information about these finite elements. Okay. We can close it now. Okay. I hope that all of you has meshed the line, so we can go on. Okay, so at this point we can come back here again on attributes and move to the second command. So geometric, we want to assign geometrical properties to a line again. So geometric line. Okay, here again, pay attention that you need to select properties coherent with the finite element that you selected.